Imagine this. You've built some very powerful APIs, but suddenly they get overwhelmed by too many requests. Your server slows down, it might even crash, and your costs go up. Because the more resources you use, the higher costs you end up with. So how can you actually avoid that and protect yourself? Thankfully, rate limiting and throttling are here to save the day. By using that, you can actually limit or cap the number of requests a client can make during a certain period of time. That way, you can protect yourself against DDoS attacks, you can maintain a good stable server with a good performance, and finally, you can also keep your costs under control. So let's see how we can actually implement that in a NestJS application. And toward the end of this video, we're gonna see how we can actually rate limit some clients based on some identifiers, whether it's the IP address, the user ID, some tokens, or some API keys. So keep watching until the end and let's get started. I have here a normal NestJS application. I have not changed anything. And the first step is pretty simple. All you have to do is just install this package, NestJS/Throttler. Let's go ahead and do that. And now let's go ahead and register this module in app.module.ts in the imports array. So throttler module.forRoot. Of course, you can also use forRoot async for dynamic configurations. And then here we need to pass in some options. If you take a look, we have throttlers, error message, and so on. Throttlers is the most important key. Here we can pass in an array of different throttler options to rate limit in different ways. Let's start with simply one. So let's say limit of 4, meaning we will only allow 4 requests per. Here we need to set the time frame. So let's say TTL, which stands for time to live. This is in milliseconds, so we could say 10 times 1000. What this means is every client can only make a maximum number of 4 requests during a time frame of 10 seconds. If they try to make more than that, they will get blocked. Now we need to register this throttler globally, let's say. So of course you don't have to do it globally, but I'm gonna go ahead and register it globally. So just like we normally do, I'm gonna provide app guard here, which is from NestJS core, and then use class, which is going to be throttler guard. And now let's go ahead and run our server and let's test it out. We already have the default endpoint here, which is get hello in the default app. Let's start making requests. I'm gonna make 1, 2, 3, 4. We're getting a response now, hello world. But if I try to make a 5th request, as you can see, we got blocked. We got this error message saying throttler exception, too many requests. And that's because if you go back to app module, we set the limit to 4 requests in a time frame of 10 seconds. So during those 10 seconds, if we try to make more than 4 requests, as we have seen, we got blocked. But now that I'm speaking, 10 other seconds has passed away, so we got unblocked. So if I try to make a request now, as you can see, we got a response. That's 1, 2, 3, 4. And now if I try to make a 5th request, we also got blocked because we are still in the time frame of 10 seconds. Now, of course, you don't have to wait 10 seconds to get unblocked. You can actually set the block duration here, which is also in milliseconds. So let's say the block duration is 1 second only. So now, every time you get blocked, we will get unblocked after 1 second because the block duration is 1 second. Let's test this out. 1, 2, 3 requests, 4 requests, 5th request. And now after 1 second, I'm gonna hit send. As you can see, we can now send more requests. And on the 5th, I got blocked. After 1 second, I'm unblocked. So by default, if you don't set this block duration, the block duration is gonna be the TTL that we set as our time frame. So just to make sure of that, 1, 2, 3, 4, 5, we got blocked. Now if I try to make a request, I'm still blocked. 2 seconds, 3 seconds, 4, 5, 6, 7, 8, 9. We should get blocked now on the 10th second. So as you can see, this is the default block duration, which is also the TTL, but we can override it just like we did. We can also override the error message. So outside of this throttler key, we can go ahead and, for example, add our own error message. Let's say, for example, whoa, slow down or something. So now with this in place, let's open Postman. 1 request, 2, 3, 4, and on the 5th we got whoa, slow down. Of course, the status code is 429, which means too many requests. We're gonna keep this as is. Now I wanna show you a small trick. If you don't always wanna use this in milliseconds, Actually, this Throttler package has some helper methods, such as seconds, for example. And then here we can pass in the seconds, for example, 10. And if you take a look here, we also have minutes, hours, days, and weeks. So for example, we could say days 1, and you could set this to 4,000. This would say that a client can make up to 4,000 requests in the span of 1 day. Not more than 4,000 in the span of 1 day, which is 24 hours. So you can see, you can actually configure this as you'd like. Let's go back to seconds, and I'm gonna go back to 10 seconds with a limit of 4 requests. Now, let's say we had more endpoints here. For example, we had get, the normal one, and then we had, let's say, I don't know, hi, which is get hi. Let's say for this API, get hi, we don't really wanna have this rate limiting. This API doesn't really need a rate limit. So we could simply say skip throttle. This is a decorator that you can add on the route, and you can also add it on the whole controller, which will be applied to all the endpoints under this class. Let's add it for get hi only this time, which is of course from NestJS Throttler. Let's open Postman, and now let's hit this endpoint /hi, 1, 2, 3, 4, 5. As you can see, I'm not getting blocked. I can keep on making requests. However, if I was to send a request to this endpoint, which doesn't have skip throttle, if I were to send 1, 2, 3, 4, 5, whoa, we got whoa, slow down. Another useful decorator other than skip throttle is throttle. So for example, here we could say throttle, and here we can override the limit that you have set here in the module, which is the default limit. So here it takes an object, and here we need to specify the name of our throttler option. By default here we have not specified a name. However, we could have done so. So we could have said name here, and we could call it anything we want. Okay, and then in this case in throttle here we would say hi, and then we would specify the options that you are trying to override, such as the limit or TTL. Now by default, if you remember, we didn't really have a name here, so NestJS assigned the default name. So here inside of controller, inside of the throttle decorator, we can say default, and then here we could say, for example, time to live, let's say 10 seconds as well, and then let's put the limit to 6, for example. Okay, so now we have overridden this default throttler option on this high endpoint. So now we can make up to 6 requests maximum. Let's try this out. Let's open the default route first, which is 4 seconds, because we did not override anything here. So 1, 2, 3, 4, 5, we got blocked. But if you try to call the second endpoint, 1, 2, 3, 4, 5, 6, and now 7, we got blocked because the limit is 6 during the time frame of 10 seconds. Now we previously said we can pass an array of throttler options to throttlers, but previously we were only sending 1 and it didn't have a name, so we said this is the default one. Now I went ahead and added 3 different options with different names, of course, so that we can tell them from each other. The first one I called it short, second one medium, third one long, because they each have a time to live specific to their name, just to make it organized for us. The first one allows us to make up to 3 requests in a time frame of 4 seconds. Second one, a time frame of 30 seconds, where we can only make up to 10 requests. And the last one, we have a time frame of 80 seconds that we have to respect by not exceeding 25 requests. All these 3 options are different rules that we have to abide by. So if a client breaches one of these 3 rules, just one, they will get blocked. So we have to make sure that we're always making requests in a way that we're not exceeding 3 requests per 4 seconds, and we're not exceeding 10 requests per 30 seconds, and at the same time we're not exceeding 25 requests during 80 seconds. I went ahead in my controller and removed all the custom decorators, and let's try to check this out now. Let's start by testing this out. I'm gonna try and fail during the first option. So I'm gonna try to make more than 3 requests during the time span of 4 seconds. So 1 request, 2 requests, 3, 4. We got blocked because we made too many requests in less than 4 seconds. Now let's try to go one step further. Let's open a timer here. And now I'm gonna make sure to fail because of the second rule. So basically I'm gonna make more than 10 requests during the time span of 30 seconds, okay? But I need to try and make it in a way that we don't fail from the first one. So I need to make 3 requests, wait 4 seconds, make 3 requests, wait 4 seconds during that 30 seconds to see how the second one is gonna stop us. So let's open a timer and let's start. So I'm gonna start the timer and 1 request, 2, 3. Let's now wait 4 seconds. 4 requests, 5, 6 requests. Let's wait 4 more seconds. Okay, we are still in the 30 seconds timestamp. Now 7, 8, 9. Okay, we can make 1 more request. 10. If I try to make 1 more, 11, we got blocked. And now this was a simple example to show you how we have to abide by all of these 3 rules. This time we got blocked by the second rule. We did respect the first one. We did only make 3 requests in the time span of 4 seconds. We didn't exceed that, but we exceeded the second rule, so we got blocked. This is just to show you a bit how you can add rules and so on. Now, let's see how we can use decorators with those rules. Previously, we said that we could skip the throttle or the rules on a certain endpoint by just adding skip throttle. But let's see if that still works when we have named throttlers with names. Let's try this out. So /hi, gonna make 1 request, 2, 3. We're getting the responses now. 4, we got blocked. Why did we get blocked when we had skip throttle? The answer is simple. Usually when we have skip throttle as is, this stands for default true, meaning for the default option or for the default throttle, we want to skip true, skip. So this is the case where we don't have a name. But since we have a name, we actually need to name the ones that we need to skip. So now if we say short true, it means we're gonna skip the short rule for this specific endpoint only. So now let's try to spam in the duration of 4 seconds and see what happens. 1, 2, 3, 4, 5. As you can see, we are able to, but now we did not skip the medium one. So, okay, a few more requests and we got blocked because we did not respect rule number 2. And here we only said that we are skipping the short option, which is this rule right here. If you actually want to skip all the rules, we have to name them all. The key is actually the name of this throttler option. And of course, we can set true or false. True stands for yes, we need to skip. False would mean no, don't skip. So here, now it's gonna skip all the different options. So we can actually spam it. Let's try this out. 1 request, we got a response. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. As you can see now, we can keep on making requests because now we are skipping all those different options here. In the case of throttle, if you remember, we said that whenever we had one option only without a name, so we only had the default option, we used to say default and then we would open here and override the TTL and limit and anything we want. In this case, okay, in this case, if you take a look here, we have 3 different rules. If you want to override some of them, one of them, all of them, you have to actually specify them here. So you would say short, and then here we could say, for example, TTL seconds. Okay, we want 5 seconds, and then the limit is 5. In this case, this means that for this endpoint, for high, for this specific rule, which is short, instead of using 4 seconds and limit of 3, we are going to set the time frame to 5 seconds and the limit to 5. However, the other 2 options are going to stay and remain the same. So we're only modifying this one and we're only overriding this one. The other 2 will remain the same. Of course, you can go ahead and add a rule for all of them. For example, say medium and then override the medium values and so on. So you can actually do a lot here. Now you might be asking, how is NestJS actually keeping track of those requests? Because as you have seen, it's actually working. The rate limiting is actually working. Well, as you can tell, we're not actually using any third-party storage or anything. So everything is being in memory. So whenever we go ahead and restart our server, all the different tabs or requests that we were keeping track of are gone. So that's not a very good way. And also, if you had some distributed systems where we had different nodes or different instances, each instance is going to have its own memory, as you know. So how can we actually properly keep track of all the requests made by different clients so that we can properly rate limit them? Well, we can use Redis or other stores. Thankfully, there's an actual community package we're going to be using so that we use Redis instead of the NestJS in-memory caching. We are going to be using this package, nestlab/Throttler storage Redis, which is, by the way, mentioned here. For distributed servers, you could use this community storage provider for Redis. If you open this up, as you can see, Throttler storage Redis, nestlab. So we're going to be using this community package. And it's pretty simple. They are just registering this Throttler module, just like we did. They have a Throttler's array. And here for storage, we have some different options to actually instantiate our Throttler storage Redis service. We can do this for localhost. This is the default config. We can also pass in a connection URL, a Redis object, or some Redis clusters here. In our case, we're going to go ahead and just do this simple local one. Of course, for production, you're going to be using for root async, and then you would inject the config service and then dynamically read from your environment variables the different connection options, such as host, credentials, and so on. So let's go ahead and install this package, first of all. Now I'm going to go ahead and remove the third rule, and let's close throttlers. And just like we have error messages and we have other options here, let's go ahead and set our storage option to this Throttler storage Redis service from the package that we just installed. Now you will see that we are getting an error from ioredis unhandled error event, connection refused, and this is because we don't have a Redis server running locally on our machine right now. So let's stop this. And I have Docker desktop. I have the official Redis image pulled. I created a container. Let's go ahead and run it now. And after running it, if you go ahead and run our server now, as you can see, it's running perfectly fine. And now with this in place, every time we make requests, the counter for the number of requests or the tracking of those requests is going to be stored on Redis rather than in memory. So every time we restart our server, or if we had different instances, they would still have one single source of truth, which is our Redis server. Everything will be synchronized correctly and working perfectly. In this section, we're going to dive a bit deeper to explain how things work behind the scenes. So how we actually keep track of the different requests and the count of those requests, how often we are making those requests, whether we should block that client if they are respecting the different rules, and so on. If you don't really care about how things work behind the scenes, that's totally fine. Feel free to skip to the next section in which we talk about how we can actually track the users based on different identifiers, whether it's the IP address or the user ID, tokens, API keys, and so on. So feel free to jump to the other section. I'm gonna mark it down as a chapter. But if you're a nerd and you would like to know more, stick with me and let's check this out. First of all, I'm using Redis Insight to visualize our data. It's a free tool that you can download to see all of your data on Redis in an easier manner, and you can filter, sort, search, and so on, just like you have MongoDB Compass as a visualizer for MongoDB. And just as a side note, I went ahead and added a third throttler option again, the one that we have added previously, named long, and I added a block duration of 10 minutes, so we would block a client for 10 minutes if they breach specifically the first rule. So if they exceed 3 requests in the time frame of 4 seconds, they would get blocked for 10 minutes. For the other two options, I left it as the default one, so I believe it would take the time to live. Okay, but that's beside the point. Let's make a request and see what happens. So in Postman, I'm gonna go ahead and hit send. We got a response. If we go to Redis, if we refresh, as you can see, we got 3 different keys. Let's take a closer look. We can see that we have 3 different parts for each key. We have the hashing part, some hash, and then we have a colon, we have long, in the second key name we have medium at the second part, and the third key has short at the second part. And finally we have hits, hits and hits. For the middle part, which is long, medium and short, we already know those names. Those are the names for our throttler options or our different rules. So basically, we can conclude that whenever we made that request, okay, we actually stored the different rules here to keep track of the different counts. Now, if you also take a look here, we can see that we have a time to live value. So for the first one, for long, we have 57 seconds left. For medium, we have 27 seconds left. And for short, we have 1 second left. And of course, the starting time to live, or the total time to live for each is, for short, 4 seconds, for medium 30 seconds, and for time to live 60 seconds. The reason here that's a difference of 3 seconds is because we refreshed it after 3 seconds basically. But here we can see that, we can clearly see that the time to live that we assign here is the same time to live for these different records or these different Redis keys. So as soon as this time goes by and we refresh, we can see that those were garbage collected or were deleted from Redis. We no longer need them. We no longer need those records. Now let's see the purpose or the values stored by those keys, because now we saw the key names. What about the values that they hold? Gonna hit 1, 2, 3, open Redis, refresh. As you can see, we have 3 records here. Why is that? Again, we have created a record. Throttler, the package, has created a record for each different rule to keep track of the counter. So here, if we open them, we can see that the counter or the hits, because the third part is the action, which is hits here. So we have 3 different hits here, and this is long. For long, if we take a look, we can hit 20 times. So as long as this counter is less than 20 times in the long record, we are not blocked. For the medium record, as long as it's less than 10, we are not gonna get blocked. And for short, of course, the limit is 3. So now if we refresh again, as you can see, they got garbage collected. We just have this 9 seconds left for long, which will get deleted because the 60 seconds would have passed by then. Now I'm gonna get myself blocked on purpose by this short rule. So I'm gonna make more than 3 requests in under 4 seconds. Let's see what happens. Again, Redis is cleaned up now. It got automatically deleted the records that we no longer need. 1, 2, 3, open Redis, refresh. As you can see, we have a counter of 3. Actually, we're not blocked. I should have done it 4 times. So if we press again 1, 2, 3, 4, now if we refresh, we got blocked. If we open this, the counter for the long is 6. That's fine. For the medium one is 6 as well, because we're still in that 30 seconds time frame, and we're still in that 60 seconds time frame. But for the short one, which now I pressed 4 times and I got blocked, as you can see here, we also got blocked, which is why we have a 4th record now, or a 4th key now. And if you take a look, this 4th key have this blocked keyword here at the end of the name of the key. And you can see before that, it says short, meaning that we got blocked by this short rule right here. And if you take a look at the time to live for this blocked record, it's 10 minutes. 9 minutes left right now, but it was 10 minutes. So we can see that whenever we get blocked, Redis is gonna create that record for us, and it will also show us which throttler actually, or which throttler option actually resulted in that block. So it's pretty simple. We have a hash, we have the name of the throttler option here, and then finally we have the action, whether it's hits or blocked. And of course, we already talked about the counter that we have here. In my opinion, this is the most important part of this video, because it talks about very practical use cases, and you might need to make some changes based on your requirements. So focus with me. So far, NestJS was able to rate limit us as a client properly. But what is the actual criteria that it's rate limiting me on Postman? So here, one request. Actually, let me unblock myself. Let's go ahead and make one request. 2, 3, 4. It actually blocked me correctly. But how did it know who I am, or how did it identify me? Well, the answer is by default, it used my IP address. So by default, NestJS with this Throttler module is going to track the requests by IP address. In a lot of cases, this is fine, and this is maybe what you need. But in a lot of other cases, that's not what you actually need, and that's not the behavior or requirements of your system. So I'm gonna give you a few examples just so that we're on the same page. Let's assume that you are blocking people by IP address, or you are rate limiting by IP address. What if there's an hotel or your own house and you have different people, 5, 10, 20 people using the same router? Technically, they have the same public IP. So every time one of those people makes a request, you are kind of rate limiting everyone and counting or incrementing the count for everyone. You're treating this whole group of people as one identifier or one client, because the tracker is the IP address, not just one user. So blocking that IP address is going to block everyone on that IP. So here, when I got blocked, okay, everyone using my router at home also got blocked. They cannot call this API anymore. So maybe that's not the behavior you want. Maybe your system is a SaaS application and you have different companies using it. Company A, company B, company C, and they are paying some subscription fees. And maybe in that subscription fee, they are allowed to make up to 10 requests to some API, maybe a dashboard API, okay, to get their analytics, dashboard data, and they can only make 10 requests per day. It wouldn't really make sense to track them by IP address in that case. It would make more sense to track them by company ID. Usually when you have multi-tenancy, you have in the header something called extenent ID. So in the header request, your users that are already logged in would send some extenent ID, which is a unique identifier for the company entity as an entity. So it could have 10 users, it could have 5 users, but you're dealing with it as one entity, which is the company, because your system rate limits companies, not users. In that case, you would need to override the default behavior, which is tracking the IP, to actually make it track the company ID, which is the tenant ID from the request headers. How do you do that? If you take a look at the documentation, we can see that just like we have storage, throttlers, error message, all those keys that we already used, we also have something called getTracker, which is optional, which is a function that takes the request and returns a string to override the default logic of the getTracker method. Now I checked the code for NestJS since it's open source, and the default logic of the getTracker method is basically just returning rec.ip. So it's tracking by IP. In our case, we're going to override this getTracker method and track by something else. So here, we could say getTracker. If you take a look, it takes a function with rec context and then return a string or a promise of a string. So here simply, we could just say this and then override this. By default, it returns rec.ip. But since our system rate limits companies, okay, we don't care about rec.ip, we care about rec.headers of x tenant ID, which is this right here. Assuming, of course, that your system, once a user logs in, will receive their token, of course, and then their x tenant ID that they need to send in every request. Let's go ahead and log this just to make sure that it's properly set. And let's see if our tracker is working. If I open Postman, if I hit send, let's check the logs. We can see we got ABC, which is the tenant ID. Now we got this log 3 times because we have 3 different rules. For each rule we are tracking. And let's go ahead and spam it to get blocked. So 1, 2, 3, 4. We got blocked. But this time we were not blocked by IP. This time we are tracking the rec.headers of tenant IDs. So if this changes, if another company, even though they are using my IP address, let's say some friend at my house has a different company and they are using the same platform, they should still be able to make requests because he did not exceed, or his company did not exceed the limits. So if I hit send, 1, 2, 3, I am able to make calls. If I go back to ABC, hit send, I'm still blocked. In this section, I'm going to show you how you can block or rate limit users on all of your endpoints if they get rate limited by one of them, if this is your use case. If not, you don't have to do anything. But by default, if you try to make a request to /hi, for example, I'm going to spam it, 1, 2, 3, 4, we got blocked. I am still able to make a call to the default endpoint, which is /1, 2, 3, 4. Now I got blocked. So basically the default behavior is rate limiting you on one single endpoint, which is the endpoint that you guys spammed or that your clients spammed. Now, if your use case or your requirement is to block a certain client on all of your endpoints, not just on one, not just on the endpoint that they spammed, you have to do some modifications. To better understand the modification that we should do, let's take a look here. If you take a look, we have this hashing part at the beginning of the key name. This hashing part is basically made out of the tracking name, the tracker name, basically here, whatever this getTracker returns. So it could be the IP address, it could be the device ID like our case. The tracker name in combination of the endpoint that you are spamming, those together hashed gives you this part. Which is why when you get blocked or rate limited on one endpoint, you can still spam another endpoint, because each endpoint is gonna give you a different hash, meaning a different key here. So if your goal is to actually block users on all of your endpoints, you would need to modify this key in such a way that you take the endpoint out of the equation. So we just need to use the tracker name itself. How can we do that? It's pretty simple. Just like we have getTracker, we can actually use generate key, which is a key, which is an optional key, which takes a function and returns the generated key. We can override it. So instead of having this hash here, which is a combination of the tracker name with the endpoint, we're gonna override it in a way that we just return the tracker string. So whatever device ID or whatever company ID or IP address, the tracker, whatever tracker it is, this will return the value, and this is going to be used as the key. Now, of course, it's better to hash it. Don't leave it in plain text, because that would cause vulnerabilities. If you are actually tracking by token or API key, it shouldn't be in plain text here, so you should always hash it. But the point is, you are taking the endpoint out of the equation, okay? So now, with this in place, if I were to spam, first of all, let me go ahead and delete the blocks. So now we're unblocked. Let's go ahead and spam the slash endpoint, the default endpoint, 1, 2, 3, 4. We got blocked. If I try to access slash hi, send, we are also still blocked. So now, because we changed the generated key and made it less unique, we took endpoint out of the equation. Once you are blocked on one endpoint, you are actually blocked on the whole system. And if you open Redis and refresh, you can see here we have this blocked right here on XYZ specifically. Again, you should hash this part. But I hope I made myself clear. This is just whenever you want to change the behavior of the rate limiting, okay? In most cases, you might not need to end this, to change this. For example, Twitter has different APIs and different rate limitings on different APIs. So spamming one would only block you on this specific API. You can still spam others or like make calls to others and so on. I hope this video was helpful. If it was, please make sure to leave a like, subscribe, share it with your friends, and I will see you next time. Thank you for watching.